Logarithm video part 14, we are continuing the function which is f of x equal minus ln x plus 2 over minus ln x plus 1. I will continue this function just in this part. And we were doing this. It's better. I prefer to do it, right? F prime of at 0, because 0, 1 was limiting point. So f prime at abscissa 0 is the limit at 0 plus to the derivative, right? And we found that the limit gives me infinity. This means that the slope, when it is infinity, this means we have vertical asymptote, right? Or vertical, sorry, tangent. So the tangent at the limiting point A is vertical, and this is important, and you'll see how it help us when we draw this curve. Let's try to do the table of variation and plot the curve. X, it's from 0 up to plus infinity, excluding E, right? Not only E, excluding 0 also. We have to be careful here. Excluding 0 also, because ln x, right? And excluded E because E makes the denominator 0. Derivative, as you remember, derivative, it's strictly positive. So it's plus. Since the derivative is strictly positive, then the function is strictly increasing function. And this is 1. As x approaches 0, I remember that as x approaches 0 plus, limit as x approaches 0 plus, right? Then we have equal to 1. Limiting point was 0, 1. It's not exactly 0, 1. It seems like it's touching this point, 0, 1. And as x approaches plus infinity, we found it at here, right? Here to the right side. As x approaches plus infinity, we have one as a horizontal asymptote. Y equal 1. This is horizontal asymptote, y equal 1, right? Horizontal asymptote. Here we have vertical asymptote. So here it's plus infinity, goes from 1 up to plus infinity, and here from minus infinity up to 1. That's great, and that's it. Let me try to find, to see if we can have particular points. Particular points is where if y equals 0, this means the minus ln x plus 2 over minus ln x plus 1 is equal to 0. This means that minus ln x plus 2, which is the numerator, equal to 0, and ln x is equal to 2. 2 we multiply it with ln e because ln e is equal to 1. This implies that ln x is equal to ln e to the power 2. We remove the ln, so x will be equal to e power 2. So when x e power 2, then the ordinate is 0, and this is a point B, a particular point. And now we draw. And that's it. We can draw the function easily. I will draw it first, and then I will show you on the Microsoft calculator or Microsoft Mathematics. Let me draw using the table of variation. And we can check by Microsoft if our drawing is accurate. Okay, first we have E, x equal E, which is 1, 2. Let me make the one a little bit. Okay, 1 more, 1, approximately 2, 3, a little bit less than 3, 2.17, right? 2.71, which is point E. This is E, and somewhere over here, let's say it's E squared, because we need this E squared, right? We need this E to the power 2 over here, B. Okay, what do we have at E? We have asymptote. So this one here is a line or dotted line. It is a vertical asymptote. To the curve. What else? We got the horizontal asymptote, which is equal to 1. Y equal 1. You can go back to the problem and you can see that this is also a vertical asymptote, which is at this point, right? Let's see. Suppose this is true. Okay. This is horizontal asymptote. What is this point? What is this? Is e power 2, okay? This point is the e power 2. This is e power 2. Okay. So this point over here is e to the power 2. What is this point? This point is, sorry, I don't have to do it like that. I have to like circle it because x not equal to 0 and y not equal to 1 approximately approaches 0 and 1. So this is point A. What do we have at A? If you remember, we have at A vertical tangent because the derivative at 0 was infinity. Derivative infinity, this means we have vertical tangent. That's great. Look at the table of variation. From 0 to 1, 0 excluded. From 0 to e, this is e, which is a vertical asymptote. What do we have here? We have vertical tangent, so it acts like this. At this point, we have like some tangent over here, and it goes up, right? And then it curve like that because it shouldn't cut the asymptote, right? So it seems that it's going with the asymptote, or the distance, it seems to goes like 0. And what else? We have at e plus, it comes from minus infinity of e plus, it goes all the way through this point B, and then it goes parallel, or sorry, approaches 0, the distance. Y approaches 0, right, over here. The distance between this line and the curve. Why? Because it is an asymptote. Because it is an asymptote. It goes something like that, right? All the way. This is exactly our curve. Let's see before the time is goes. Let's see if we can know that over here. All right, graphing. It was all right. It was minus ln x plus 2, right? Plus 2 divided by minus ln x plus 1. Okay. Enter. Graph this function. Let me make it a little bit smaller. Can you see it? Over this point here, it's A, right? 0, 1. Over this point here, what do we have? We have like it's tangent. I know it's not clear, but it's like it's tangent at that point, right? And it goes all the way. It goes all the way up. 1 E, I mean, is 2 point something, is a vertical asymptote, and then it goes from this vertical asymptote, and then it goes all the way to y equal 1. If you, I don't know here, yeah, it goes all the way, right? It goes all the way at, because e square is a little bit far away from e, you know, so it goes with this x-axis until it cuts the e square, the point B at e square, and it goes all the way up to the line 1, right, parallel to the line 1, and that's it. Let me just put a point B here. This is a point B before I forgot, right? And that's it. And this is point A.